In this video, I want to quickly discuss this problem from the textbook about the supply and demand curves. Before I give the definition of these curves, let's first take a look at the variables p and q. So this p variable on the vertical axis here is the price, and the q variable on the horizontal axis is the quantity of some product. And what is interesting about this example is that in economics, the price is actually an independent variable when we talk about these supply and demand curves. And the quantity Q is a dependent variable. So this is a real example, in this case from economics, where we put independent variable on the vertical axis. Just like in calculus, we sometimes think of the y variable as an independent variable on the xy plane. Now let's take a look at the definition of this supply and demand. So supply is the quantity of some product, let's call this quantity Q, that producers are willing to provide at a given price P. And the demand is the quantity of product, again let's call the quantity Q, that consumers are willing to buy if the price of this product is equal to P. Now actually both of these are measured per some unit of time. So depending on the example, this could be per week or per month or some other interval of time. But once that interval or that unit of time is fixed, we are talking about the quantity of the product as a function of the price. And with this definition, now it's natural that when the price is increasing, the supply curve is also increasing, because the suppliers, of course, are willing to provide more product if the price is higher. And on the other hand, the demand curve is decreasing because the consumers are willing to buy less product if the price is higher. Now you see that it's quite natural to think of price as an independent variable. And it's quite natural to say that at this particular price, the consumers are willing to buy this quantity of product. And the textbook is actually giving these two curves as a function of the quantity. So it's thinking of the quantity as an independent variable. But in that case, you can actually see that it's quite unnatural to phrase it that way. To say that, for example, at particular quantity Q, the price P should be this much, so that at that price, the consumers are willing to buy this quantity of product Q. Right? It's much more natural simply to say that at this price, the consumers are willing to buy this quantity of product Q. And so no matter how you phrase it, it's actually much more natural to think of price as an independent variable, which is indeed how it is viewed in economics. And so to rewrite these curves in this more natural way, we can simply take this particular curves from the textbook. So for example, the supply curve is given as a price as a function of time 11 plus Q over 40. And we can solve for Q. So here if you solve for Q, you will get Q is equal to 40 times P minus 11. And so here quantity is given as this supply function as a function of the price P. And in the same way, you can take this demand function from the textbook, and if you solve it for Q, you will get quantity as this demand function as a function of price. So written this way, the formulas actually reflect this fact that it's more natural to think of P or price as an independent variable. Finally, if we take a look at this graph again, we see that we have this special point here where these two curves intersect. And this is called the equilibrium point because at this particular price, the supply and demand agree. Okay, and so this particular price is an equilibrium price. And if you want to find it, you can simply equate these two functions that we just wrote and solve for P. So in this particular case, the equilibrium price will be equal to 14.